Bismillahirrahmanirrahim. Assalamualaikum. My name is Kamsiabuddin and I'm gonna talk about our paper today, which is prioritizations on anti-lipidemic in surface water of Malaysia using this best approach. Increasing this lipidemia means more anti-lipidemic will be prescribed. Once consumed, 70% of the drugs will be excreted in our urine and 30% will be in our feces. And all these excretions will go to the wastewater system. But however, okay, the anti-lipidemic can be detected in the environment, which means that they survive in the wastewater treatment during the wastewater treatment and persistent in the aquatic environment. And there's a lot of toxicity tests that have been conducted looking at the effect of this anti-lipidemic on several aquatic species. And both statin and valproate shows have the adverse effect on the growth hormone, morphology, and also the maturations of these aquatic organisms. In Malaysia, there's a limited of anti-lipidemic research on our surface water, and then we also know that the wastewater treatment plants that we have in Malaysia were actually not designed to eliminate of these emerging contaminants, but it's not practical to run toxicity tests for all, and it's not ethical. So therefore, we need an alternative approach that is practical, relevant, cost-effective, and time-saving, but could help us in identify which of these anti-lipidemic that we should focus more on in terms of its adverse effects or toxicity on the aquatic or non-target organisms in the environment. With that on mind, we come up with two objectives, which is to identify, calculate the predicted environmental concentrations for each of these anti-lipidemic, and then we gonna classify which of these anti-lipidemic actually is the most concern, and then ranking them from the lowest to the highest risk to the aquatic organisms. For the methodology, we actually use a computer-based research or desktop-based research, where we just use the secondary data and we collect the data from the Malaysian Statistic on Medicine, which published in Ministry of Health Malaysia website. And from there, we calculate the predicted environmental concentrations. We incorporated in the formula, we incorporated the informations of consumptions, okay, of the anti-lipidemic per year, the HAB, or number of populations, the volume of wastewater per person per day, and then the dilution factors, where we set at 10. FS greater is the fraction unchanged of these anti-lipidemic, and FSTP is the 1 minus the wastewater treatment plant removal efficiency. And after that, we calculate the risk quotients, where the risk quotients is actually the ratio between the predicted environmental concentrations with the predicted no effect concentrations for algae, daphnia, and fish. And based on the RQ value, the risk quotient value, then we determine if the antilipidemic is actually at high risk, medium risk, low risk, or insignificant risk to these aquatic organism. However, after we calculate the predicted environmental concentrations PEC, and we compare the PEC value for both years, it seems that there's a plot twist, okay, between the usage and these predicted environmental concentrations. At first, before we calculate these PEC, we assume that simvastatin will be the most toxic because we use more simvastatin compared to the others antilipidemic. But to our surprise, when we calculate the PEC value for both years, gem is actually the highest predicted, has the highest predicted environmental concentration compared to simvastatin, rovastatin, and so on. And simvastatin with the highest annual usage seems not even half the gem fibrosil PEG value. And this really interesting because it shows that we cannot just using the annual usage to determine the concentrations, to determine the possibility of its um, availability to the aquatic organisms, or to assume its toxicity to the aquatic or non-target organism once it released in the environment. So based on this graph, we could see that gem fibrosil has the highest PEC value compared to simvastatin, robustatin, lovastatin, atorvastatin, and then the lowest is cyprofibrate. But then, will this be enough looking at the PEC value, or looking at the concentrations in the environment to presume that the highest concentrations will be the most toxic? And if we calculate the RQ value from the for these antilipidemic, we can see that the RQ value for all the studied antilipidemic for both years were actually less than 0.01. So this actually helping us to understand that it's not enough just to stop at the stop at the concentration or monitor the concentrations in the environment. It helps us to to acknowledge that we need to know the possibility of these concentrations will have adverse effect on the organisms as well. So based from our study, gem fibrosil PEG was the highest, followed by simvastatin and so on, and cyprofibrate is the lowest. And also based on the PEG value compared with the measured one, it seems that the PEG that we calculated are reliable and reflect the real scenario within the range of measures, within the range that have been measured in the real environment. And if we look into the RQ value, all those antilipidemic for both years are really low. less than 0.001, which can be concluded as insignificant threat to the aquatic organisms. Therefore, we could say that these anti-lipidemic were not in the list of the most concerned emerging contaminants based on its effect on the environment of Malaysia.